Good evening, ladies and gentlemen. Welcome into L9 Productions. Here we have a special podcast for you guys today from the Discord of 17 Research Group headquarters. We've got Chris Hunter with us, we got Kay Bailey, and we got Queen 17. And the topic we are talking about is physics and some quantum physics. So buckle up, guys.
Hello, thank you. My name is Chris Hunter from the 17th Research Group headquarters. Prior military, police. I've done just about everything there is in the world to do, from busboy to washing dishes, welder, and self-taught in the sciences. So I'm here. With me today is KT Bailey and Queen 17.
Hi, I'm Queen 17. I'm a mixture of many things, but the main thing is a true patriot. And I feel that we must move forward each day, learn all we can about any and every subject, always have information to cover what we find, and to continuously overturn each and every stone to help us on our way to our main goal of letting everybody know what a true American is. Thank you.
Thank you for having me. I'm Kay Bailey, prior military, just like my friend Chris here. Avionics man, electronics, do that full-time, electronics now. Literally the son of a rocket scientist. My mother is a nuclear physicist, so I've always been interested in the sciences between chemistry and physics, and it's really helped me to expand my knowledge and continue on. I've got a great resource to go back and ask questions to, so I'm just here to share, and I'm new to this platform, so please forgive me if I have some fumbles along the way, but thank you for having me.
All right, guys, thank you for all joining us. So we're going to go ahead and tackle our topic of physics. I'm going to hand it over to Chris Hunter, and he's going to go ahead and lead the conversation. Guys, take it away.
Okay, well, physics is kind of a big topic in my book. It's kind of intimidating at first when you hear it. A lot of people shy away from it, and a lot of people are like, whoa, what's that? And I just think that people should not be intimidated and relax and just dive into it wherever they want to start, but just kind of try and absorb as much as they can and try to understand their surroundings and their world and how things kind of are all connected together. And there's a lot of interesting ways, I think. Bailey, you have anything to add?
No, I agree. And basically we're coming, our technology is exponentially expanding over and over and over. They say now, every 5 years to 10 years, we're doubling our technology. And there's only so much you can go with the primary physics, the natural physics, and then they've gone into quantum physics, which is basically going to the atomic and the subatomic level to try to basically figure out how it works, how we can utilize the most minute particles and so forth to, for information processes, for clean energy, for, space travel and so forth. It's a really exciting field, and it's awesome to learn about it.
I read an article right when Q had come out, and it was about quantum encryption. And they were talking about how they were able to use photons to write on, I think it was, or for the encryption. It was really crazy. And I had a really hard time going, how they were doing that, and how do they capture those to read them? So I was like quite amazed at that. But the DoD paper I was reading at the time, which I was unable to find again, was saying that for the most part, all of our encryption that we have today is easily hackable. Like if China wanted to, it's just a matter of how much time it would take to hack it. And that a lot of their stuff was best done with public keys and stuff like that.
Well, part of the encryption today is it's linear. Everything is based on ones and zeros. And if you have enough time to be able to sort out through the ones and zeros, whereas what you were speaking of earlier about photon, which is a light particle, and the new quantum computers that they're coming out with, instead of having a linear encryption equation, you're able to layer the information on top of each other. So what you're doing is, instead of sending a bit or a byte packet through, you're actually sending information on layers of light particles for the encryption process.
So let's say we're at Star Trek and we were shooting a photon torpedo. Would it also be packed full of information? Just kidding. Sorry.
So no, well, even that was something that we were talking about the other night, as far as you look at these TV shows from the 60s and stuff, Star Trek, you had the communicator. Well, hell, that's the flip phone of, 10 years ago, or the photon torpedo is basically a laser projectile of light of great intensity. It's amazing how what was once science fiction is coming into reality today.
Ooh, reality. What a good point. That reminds me of a couple topics I heard when Trump became president. Not that it has to pertain exactly to this conversation, but it kind of does. There's the series of books about Byron Trump and his adventures in time. And then there's the one about John Titor, Titor, and his adventures in the early 2001. There's a lot of stuff out there, and a lot of conspiracy about time travel and Trump and his family's connection to Tesla. So it's interesting.
Now, I'm not aware of the connection with Trump and his connection with Tesla. Can you expound upon that?
Well, Nikola Tesla was considered to be somewhat of a concern to the state, so to speak, the United States. He just knew things that could get him in a little bit of trouble and freaked out a lot of people that were in charge that didn't have the knowledge to understand it. And they kept a good eye on him. And then when he died, he ran in there, the FBI did, and they snatched up all of his stuff. And part of that stuff was a bunch of trunks that had his paperwork in it, and designs and patents and stuff that he experimented with. And when they did that, the scientist who actually did the research, went through it all, was no one except Trump's uncle. So Trump's uncle got first dibs on everything and went through it all. And one of the things he did find was a time traveling device thought up by Nikola Tesla, but it said that there wasn't enough technology. Current technology wasn't advanced enough to actually build it. And was supposedly had given this stuff on to Trump. That's the hearsay of that part. But he did go through it. It's in the actual FBI vault where Trump's uncle did go through Tesla stuff, though. That is fact.
That is interesting. That is, the theory of time travel, you go all the way back to, H.G. Wells and things of that nature that have talked about time travel, and even quantum physics and chaos theory, talk about the possibilities of time travel. Being able to bend light upon itself, or thinking of time as a linear line through space, or even you go into that, we've talked a little bit about this, is, alternate universes with different timelines within it.
Yes, I'm of the belief that not only is our world not flat, it's round, but it might be, I guess, flat in some other parallel universe. but not this one. There's my dig. But I feel that there are things about this reality that are different than they used to be, whether it's a Mandela effect or flat ribbon worms that shoot out these weird things in their mouth. There's just stuff that's here now that I don't remember growing up ever once as a kid, or all the different dwarf planets in our solar system on. So my interpretation is something's changed. So how does the quantum mechanics of a computer work? What's that all about? There's qubits or something like that?
Yes, there's qubits.
I know that they have to freeze the processor down to I think it's like negative 200 and like 70 something Celsius. Super cold.
Well, basically what you have is just like for the actions and stuff, just like computers now, that when you have your microprocessor, you've got to put your fan on it and your cooling coil and so forth. When you're running energy at that high rate of speed, unfortunately, one of the main things that you have to worry about is it creates heat.
Right. I think the heat also brings about problems with the magnetic field and so on. I guess one of the problems they do have, and they've accounted for, was eliminating the magnetic fields from even the Earth in the room there. They have, I think it is around 30 layers or so, different protecting from magnetic fields to gravity waves.
Well, part of what happens is, because you are running, say you're running on photons or particles of light, you have to be able to maintain that in the magnetic field, or else your information or the travel is going to be distorted.
I hate when that happens. It usually crashes my computer when they get distorted. Okay, it's 50,000 times less that of Earth's magnetic field in the room. They pull a vacuum that is 10 billion times lower atmospheric pressure. So that's pretty insane. And that's all so that they have the best conductivity and the least amount of resistance and effects from whether it's ambient or geomagnetic forces and stuff like that.
So if they create the perfect atmosphere, the progress is basically unlimited.
Unlimited, and then they produce another me.
Understood, sir.
The perfect atmosphere, and ta-da, Chris is here.
And they have developed these items to be put into use, I'm sure.
Yes. How's that computer work, T?
Well, let's see if I can bring up, see if this link will work here. Hopefully everybody will be able to.
It's in your slides.
It is in my slides, and this is where I am new to this platform, and I do not know exactly.
That's where those handy guys in production will bring that up on the screen for us when they do the final cut. Right, production? So then it had the quantum D wave, and then they've gone to the quantum D wave 2. So they're moving along pretty fast. So I think they're moving, 1 year is about compact down to about a week or a month now of advancement.
Well, you think about it, when you had everybody's seen the movie War Games with the computer Joshua that was the size of a room. It took a man computing it out, 100 years to compute it out. Then they were able to break it down into years. Now they're able to break it down into months. And with the quantum computer, because of the rate of information and be able to layer the data, you're talking about 25, 30 years ago, what took a year to compute now will take minutes.
Wow, that's amazing.
Part of it is with the free flowing of information in layers, instead of sending that, again, the garbage in, garbage out quote is ones and zeros, you're sending almost every variable outcome at the same time. So one of the things that, everybody, the big rage right now is AI, artificial intelligence, robots, things like that. And being able to layer this information, being able to layer the data, the speed of processing will completely enhance. And then they're working on the flip side of that to where this processor and things can take environmental elements out and be able to interpret that. And so it's not only information in, information out, it's basically learning by its environment. And they're trying to utilize the quantum computer to be able to take that information in and add to the multiple variables as a layer to, in essence, learn. And that's the scary part. That is a bit scary.
To think for itself.
Not necessarily think for itself, but to be able adaptability
At a quantum speed
at a quantum speed
and level. So let me get this straight. We're experimenting with AI, and then we said, hey, it would be really smart for us to give it a quantum ability. And they all looked around each other and said, yeah, let's do that.
And I think that one of the things we keep saying the word quantum. What exactly is quantum? Basically, that is getting to the most minute base level of an atom or the molecules that make up an atom, and being able to manipulate them to be able to utilize that fine, minute space to utilize it to our advantage.
So I was watching the guy here that helped develop this once on YouTube. It's a great ability for Americans and humans to communicate in the new digital community square. YouTube is about how these quantum computers are actually, in theory, connected to all the other quantum computers through all the other parallel universes. That seems pretty insane to think about. And that's one of the reasons that they're able to calculate such to accuracy. I believe it's 97%.
And basically what they're saying by that is a particle of information can be at two places at one time. That's what they are trying to prove now, being in two different states.
Does that work with wipes?
Wrong
I
kind
would never do that. I don't want that. I'm just asking.
Wrong kind of state.
Okay, got it. Money towards no.
Basically about control.
Usually it's about for men.
But just think when the quantum physics outbounds man's intelligence and they can no longer handle the level that it rises to, what happens then?
The woman comes in and sets down the law.
Yeah, I think I see where you're going with that, Queen. Whoever owns the power or has control of it basically has the power. It's, that prime example people talk about, power is knowledge, or knowledge is power. You're right. And then to the point to where when we get to a point, who is going to have control? In my belief, it should be the people. It should be for the good of everybody. But that is something us as Americans, as patriots and stuff, why we're here today is, we're fighting for our freedoms and things of that nature. And this is right there with it. This technology is going to happen regardless whether we like it or not. Either it's going to be for nefarious reasons or hopefully it'll be for good reasons.
Correct. That's why our fight is so important. And no one should be in it for the wrong reasons. Now, the evil, if you want to say that, have been in control or thought to have been in control, and we have blindly followed because information we were just not recognizing that we're discovering from years ago that was put out there publicly but was overlooked. So I'm thinking the same theory goes here. That's why we must win this battle to be able to control the narrative.
Yes. The quantum computers and information have been out for a while, and the American public has just, in the last 8 years, been privy to some of that. And it's widely spread through NASA, NSA, private industry. That Google has a few, and China has some now. And so the information and this technology should be controlled by the entity that we trust, not a nefarious one that would be willing to, do stuff like, make up wars or pull some kind of wool over the eyes of the American public or have some kind of alternative plan to it. Hopefully there are going to be some kind of good people there. They're going to make it for the good outcome of the world and the planet and making it a better place, clean energy, that kind of stuff.
It's a wonderful thing to have. Like I say, the directive and the narrative and how we step forward with this, and the more we understand about quantum physics, the better we are at advancing and using it for good and taking out those who have nefarious means and ways of getting in there.
And what is so amazing about this quantum physics, I know people have talked about it for years. I mean, it goes back to the 30s. And actually, Einstein tried everything to knock quantum physics down, or the thought of quantum physics. The first part of a lot of his writings and stuff like that, he was trying to prove that on the subatomic level, quantum physics was a phony science. But we see now that it's come so far, and it's not just about computers. It's about controlling light, utilizing fission for space travel, traveling at light speed, being able to create wormholes. There are so many different entanglements in the quantum field that what we're talking about this evening is just one of the many possibilities.
Right. Like Waterpicker pointed out, Einstein said, God doesn't play with dice. And I think that in a lot of ways, yeah, there is the validity to that. And we are playing with dice a little bit here with quantum stuff. Our ability to excel past our own means has probably never been more real than it is today. 5 years ago, they were saying that we would be looking for alternate planets to look for life. And we've already mapped out about 1,000, 10,000. It's just amazing how many we've already found.
And that now that we have found those planets, I mean, we're nomads by nature. We are willing to explore the unknown. What is left on Earth other than the oceans? There's space, and we're in such an infancy in that, and we need these new technologies to be able to take the next step.
Yeah, I was reading a article on wormholes and how, in theory, they're out there. And now that NASA has come out publicly and announced that there are wormholes around the planet, and there have been forever, they open up every 8 minutes between here and the sun and close. open and close every 8 minutes. And that's kind of scary. They're there. They proved it. So what have they proved? How do they prove it? Did somebody go for a trip? Did we send something? I think there's this whole realm of topics and things that we could discuss here eventually as we crack the door on this.
Oh, exactly. Going to the quantum level on that too is that, one of the ways that they are talking about creating wormholes and stuff like that at the subatomic level, being able to travel between the particles. And they call it quantum tunneling. And that's another theory that they have, how to create or to exist in a wormhole as a means of traveling across space.
I used to kid around about having a quantum VPN flux capacitor for my encryption. Do wormhole tunneling through space and time so they can't get my stuff.
But with these new computers and stuff like that, if they are able to make them, relevant and they're there, they've got them on a small scale now. And just like you were talking about the D-Wave and stuff like that, it's the future is amazing.
Very much so. So I'm not sure how. Sorry, go ahead, Queen.
No, I was just saying, I personally think they know much more than they put out, but they're trying to slow-mo it to not overwhelm people.
You can't turn back time. Going forward. Well, I don't know how deep we're going to get into this tonight, or if we want to just skim over it to now and open up some topics and just kind of see where it goes from here for the next episode, or anybody have any questions or directions they would like us to talk about, look into? Cricket. Well, if there's nothing else, I'm Chris Hunter from 17th Research Group headquarters. And that was my 2 cents worth. And
I'm Kevin Bailey from 17th Research Group, and that's my 2 cents worth as well.
This is Queen 17, and does anybody have anything they would like to add, or that they know that we didn't cover, or that you can verify?
well, if that's it for now, then until next time, we'll get some feedback and we'll put together some juicy topics. Thank you.